You probably need that.
Good morning, everyone. We're here today with Chris Livingston from Pillar to Post out of the Portland area. Chris is going to talk to us today about new technologies for homes. He's going to talk specifically about hot water on demand, heat pumps, home automation, and then talk a little bit about your favorite thing, air conditioning, as we get into the summer months here. A little bit about Chris. He's always been interested in home structure and remodeling and is an avid woodworker, often building custom furniture and cabinetry for clients. After getting into the home inspection business, he served on the board of directors for the Oregon Association of Home Inspectors, which is the local American Society of Home Inspectors chapter, for 2 years. Chris studied architecture in college, and in 2004, he bought out his business partner, his dad. Chris lives in Tigard with his wife and 3 children. So without further ado, here is Chris to talk to you about new technologies for homes.
All right. Well, thank you everybody out there in the internet land. Normally I do these classes in front of people, so it's a little interesting when I'm on the other side of a computer from you. So please, if you have questions, jump in. I'll have somebody that can jump in and interrupt me and ask the questions for you. But we will get into this now. So my name, obviously, Chris Livingston. I have been doing this for a while. Sorry, I think I just clicked something here. Oh, there we go. There we are. Okay. So before we get too much into this, hopefully no one out there works for the Construction Contractors Board, but if you do, they have said that we are only allowed to do these classes if we're doing them as a customer service or as a public service, not to try to get business out of this. So that's what this is, especially with OAR. I mean, obviously I'm reaching people that are way outside of the area I work in. So I am doing this to try to help educate you guys on the different parts of homes. So we are going to talk about some new technologies, and new technologies, not just new techno gadgets, but things that have improved with what we already have in our homes. So we're going to talk about hot water on demand, heat pumps and what's new with those, some home automation stuff, new technologies in air conditioners, and that is an exciting one. And I am being a little sarcastic, but it is kind of interesting. So hot water on demand. I have to say that this is probably one of the most commonly asked about upgrades in a home when we're doing a home inspection. And so I kind of wanted to cover this. And I'll tell you, I tend to have a little bit different view on green technologies than some people. I always like to know, does it actually do something? Is it better? Is it saving money? Is it saving the environment? And so I don't like to just do something just because it's supposedly green. I actually have a whole class on that one too. But hot water on demand, if you're not sure what I'm talking about, there is no tank. You just have a big kind of box on the wall of your garage usually. So it's not storing any water. And as the water is needed, you turn on your faucet and the water heater instantly starts heating water. So the cold water starts flowing into the system. You've got very powerful high BTU gas burners that ignite and are heating that water as it passes, and it comes out hot. Now, one of the misconceptions, and I get this all the time from clients, is, well, I turned the water on in my master bathroom. Why isn't it hot instantly? This is called an on-demand hot water heater. And they don't understand that the water still has to get from the water heater to your faucet. You can't just instantly get it there unless you actually have that on-demand water heater right at the faucet. So it's still going to take a minute for the water to get there. It is not going to get to your faucet any faster. It's just not being heated all of the time. It's just being heated when you need it. So here's kind of a little diagram of it. And especially nowadays, most people have seen the Keurig coffee makers. It kind of is like a Keurig coffee maker. It's got little coils in there. It's got water that runs through it. You can see the flames, and those start burning and instantly heat that water up. And if you haven't seen these, on the left, we've got the newer on-demand kind of a boxy looking water heater. They've got different shapes, but same basic configuration. And then on the right-hand side, you've got an older typical tank water heater. Some of the key benefits, well, you get all the hot water you want. You don't have to worry about running out of it. It is more efficient to heat it as you need it, as long as it is supplying enough hot water for you. You don't have the standby loss, because if a tank water heater is just sitting there heating 50 gallons of water, eventually that heat is going to leave the tank, even if you're, even if it's a very efficient water heater. So it's still going to lose some energy. Also, the nice thing is it gives you more space. You don't have that thing taking up a corner in your garage or in the basement or a closet somewhere. It's just up on the wall, it's out of the way, and it does save you quite a bit of space. So I've had clients that do it just for that reason alone. The downsides, and this is what they don't always talk about when they are trying to sell you on a tankless water heater. The upfront cost is extremely higher than a regular water heater. Not just buying it, but also installing it, because usually things have to be reconfigured to make it actually work. They can't just pop it on the wall and connect it. They've now got to run different things to it. They've got to change the plumbing a bit. And not everybody knows what they're doing when they're installing these. I've had people that thought they knew what they were doing install it, and it just did not work right for the client. It does require an experienced technician to do it, and not just install it, but also to help you size it properly. One of the biggest problems we see is people are very excited. They want to get a tankless water heater. They want that instant hot water that is going to last forever and never run out. But they go to George Moreland or wherever to buy it, and oh my gosh, that basic model is $1,500 or $2,000. And now the guy is telling me I really need a $3,000 one, and that doesn't even include installation. And so a lot of times people end up going with way too small of a unit, because they're thinking, oh, well, we're trying to save the environment. We're trying to be good. We're trying to save money and use less resources. So we'll be better about our hot water usage, and we will get the smaller one. And then all of a sudden things don't last, or they don't have enough hot water. The other thing too is if the power goes out, you do not have hot water, because it needs electricity to run, even though it's gas that is running it. So getting a generator as a backup is usually kind of a necessity if you're in an area where you could be without power for a day or two. So does it really actually save any energy? That's kind of the big thing. So the energy factor, you really, if you're trying to actually pencil things out, you need to look at these kind of things. You want to estimate your total energy cost for that hot water. And energy factors for the typical tank style hot water heater is about 0.55. So on average, every dollar you spend on gas, you're getting about 55 cents of hot water. So every dollar you burn, 45 cents of that is going up the flue and just going away. With the modern tankless water heater, they're up to about a 0.84. So you're definitely using more of your energy dollar to actually make hot water. But does it actually save money? And so a 20% energy savings is realistic in comparison of a modern tankless system, but it depends on how you're using it. So, and also how long you're going to use it. If you actually look at how much it costs to put in just a regular water heater versus one of these tankless, it could be anywhere from 4 to 9 years before you actually make any money back to pay for that difference. And so if you're only going to be in the house for a couple of years, it doesn't always make sense to actually upgrade, because you are never going to save that money. These systems tend to last about 20 years compared to about 10 to 15 years for a tanked water heater. So as long as it does last you that long, and you're going to be in the house that long, you can actually save a bit of money doing it. Let's see what else here. So this is where we tend to see it. And when I ask, especially in audiences where they're in the room, I'll ask them who has them and who has actually saved money on that. And everybody raises their hand that has it, and they're all excited about it. But then you ask them, did you actually save any money? They almost always say, no, we didn't. And the reason for that is, yes, they are saving money and they're making hot water more efficiently, but they are using more hot water because, well, I don't need to take a shorter shower because I'm saving so much money with this tankless water heater. So I can take a 15-minute shower instead of a 5-minute shower. And so their energy savings are almost always next to nothing, if actually a little bit more expensive, because they've started using more hot water. Because as soon as you turn it on, you've got hot water, and you can keep doing it as long as you need to. The other thing is, if you're in an area without gas, you can get electric ones, but they just are not cost effective at all. Electricity is the most expensive way to create heat. And so if you're using a tankless electric water heater, the size you would need to actually supply a house would be huge, and it would just be a massive, massive energy drain on that house. And also, if you're especially like the Portland area where you're doing the smart meters, where you can pay more if you're using at peak hours and you save money at lower peak hours, you actually will end up spending a heck of a lot more money doing that. Little electric instant hot water heaters work well for at your kitchen sink if you want to make your tea or instant coffee or something like that. You'll see them in gas station bathrooms. You do not see whole house electric tankless water heaters. They're just not efficient at all. Any questions come up on the tankless water heaters?
No questions.
Okay. I must be explaining it extremely well, so that's a good thing. The other thing too is I tend to see from clients, we have learned to kind of warn people on existing homes where a homeowner has retrofitted a house with a tankless water heater. Because of that initial sticker shock, most people end up going with the cheaper one than they really should get. And the biggest downside to getting a smaller one is you might be able to take a shower with it, but the second somebody tries to use a faucet or run the dishwasher or run their washing machine, all of a sudden everybody gets cold water. And so we have warned clients to ask the seller, what size did you get? Did you have it sized by a plumber? Has it been adequate for you? Because we had one where the client was just mad at us and they were blaming us because they couldn't take 2 showers at the same time. And it turned out the neighbors had said, oh yeah, when they remodeled, they put that thing in and they hated it. It was the worst thing they ever did. They wished they'd just put a tank water heater in. And of course, they had not told the buyers any of this. So they were very mad that we couldn't tell them the size wasn't right for the house. And we just can't do that, unfortunately. All right, so let's talk about heat pumps. So this is obviously not a new technology. We've had these for a while, but there are some new things that have come about and are getting more efficient. And so we'll talk about what a heat pump actually is. There's air source, there's geothermal, and there's also some new applications with that. So a heat pump, and I explain these, or I try to explain these on inspections to clients and to realtors. We're in an area, at least in the Portland market, where we have gas pretty plentifully. And so we don't have as many heat pumps around, and people just aren't used to them as much. But it is a device that moves heat from one place to another. And it gets very technical and complicated. Most of the time, I just tell people, just pretend it's magic and that it will pull hot air from outside, even if it's cold outside, and it will bring that air inside. And then people tend to, okay, I can understand that, and they're okay with that. You don't have to understand how it works exactly. It is interesting if you're into this kind of stuff. But some of the examples that we have in our everyday life, your fridge is basically a heat pump. It is pulling cold from the room and moving it inside, or it's actually pulling heat from the inside of the fridge and moving it out. Your air conditioner, that's a heat pump that's only working as an air conditioner. So that's pulling heat from the inside of your house and moving that to the outside of the house. So temperature gradient. Again, this gets a little complicated sometimes. You know, I'm not the smartest guy in the room, and I always admit that, but heat will flow from hot to cold all on its own. It's just, that's the way physics works. It happens. So if you want to move heat in the other direction, so you want to go from cold to hot, then you need, like a refrigerator, you move heat from the cold interior of the fridge into the kitchen where it is much hotter. And heat does not want to move this way. So it requires energy in order to do it. If you've ever pulled your fridge out and felt how hot it is behind it, that's because it's pulling that heat from the inside and it's moving it to the outside. Oops, skipped a little too fast here. Air conditioner, same kind of thing. Just this is what most people don't seem to understand is even with an air conditioner or a heat pump, you still have that unit that's sitting outside with a big fan in it. It's got the fins on the outside. That's doing the work outside. You still have a furnace that moves air and you have your components inside. So with air conditioning, you can see the red arrows there. So that's coming through the return air. It's running down into the furnace. It's going across that little V-shaped coil up at the top. It's then creating cold. That cold is blown into the house. The coolant absorbs the heat. It's taking it through the air conditioner. Then that fan is helping to spin around, blow the air across the coils, remove the heat from that, and just kind of keeps going. So it is, from a scientific standpoint, it is pretty simple. It can be kind of complicated to understand, and I get that. But again, just pretend it's magic, and most of the time people get that and they're okay with that. So air conditioner or heat pump. An air conditioner really is a heat pump. It is just missing one little part that can reverse it and turn it around to start bringing heat inside the house instead of just cold inside the house. But that's why heat pumps are much more expensive than an air conditioner. They've got to have that reversing valve in there to help take the heat and change the direction things are working. Let's see here. So I think we kind of covered that. Air source heat pumps. This is the most common one that we have around here. So it is an air conditioner. It's a reversible air conditioner, and it is called an air source heat pump. It is used to heat your house, and it extracts warmth from the air outside and pumps it into the house. It is very cost effective depending on the climate you're in, but again, depending on where you're at, if you don't have natural gas or you don't want to have a propane tank, it is definitely going to be a much more cost-effective way to heat your house. So why heat with a heat pump? Well, it works great, again, if you're in an area where you need it. In the Portland area, when I see a whole neighborhood that has natural gas, and I see that they have a nice new heat pump, not just an air conditioner, but an actual heat pump and a gas furnace, it tells me that they have had a very good salesperson, because say a heat or an air conditioner might be $3,000. A heat pump is probably going to be $4,000 or $5,000, and you really don't want to use a heat pump if you already have a gas furnace, because heating with electricity, no matter what you're using, is still going to be much less effective than using the gas furnace. And as long as it's not too cold outside. We had a vacation place in Eagle Crest outside of Redmond. There was no natural gas in the development, so we had heat pumps. It gets cold enough out there, though, that at some point when you get down below freezing, that heat pump no longer can really bring any heat from outside anymore, and then you're just switching to your electric furnace. And so then you're really racking up the electric bills at that point. Geothermal heat pumps. So this is something that has been around for a long time, but we're starting to finally see these a little bit more. The problem is they're expensive, but they work extremely well. And the reason they work so well is if you're using an air source heat pump, that air gets too cold, you can't heat anymore with it. But with a geothermal, you're actually using an area where it's always about the same temperature. So that heat pump is always going to be working. So you look at this little gradient scale here, there's kind of that balance point where the cost of things and the temperature and everything works out. The heat pump capacity, etc. Let's skip to the next thing. It'll be a little more explanatory here. So if the balance point is the problem, the geothermal is the solution. So say you're in an area that is just too cold most of the time. You're never going to have a good environment to use that heat pump. So then a geothermal heat pump becomes very good because you have a stable temperature to draw heat from. So what they do is they dig down into the ground, get down far enough that that temperature stays the same year round, and they can use that area to bring the heat from. So here in this little diagram, they've actually got pipes running down into the ground. And so it might only be, it could be 20 degrees up in the air, but down low enough, you might be down at 50 or 60 degrees even, or even 40 degrees. That's still going to be much warmer and be able to pull the heat from that area. So it is very cost effective for heating, and it is usually a fraction of the cost because you're not using electricity, you're actually using water pumps, and so it's much more cost effective. But the installation costs are the problem. And it can take 12 to 15 years to make your money back on them, because now you're basically digging wells over and over again. And so they can run those pipes down far enough and run the water through them. It can take 12 to 15 years to make the money back on something that, say, a electric heat pump system might be $10,000. You might be looking at $20,000 or $30,000 or more, depending on the area you're in order to install a geothermal system. So that tipping point, geothermal systems are really not new, but the conditions that we live in are. So we've gotten to the point where energy is getting more expensive all the time. And so it actually, the numbers start to look more attractive, especially if somebody's building a property that they plan on being in the rest of their lives. They know they're going to be there a long time, and so they know they can actually make their money back on it. Also, there's other, like, okay, we just covered that. The increasing demand. So there's more manufacturers. 20 years ago, there was hardly anybody making these kind of systems. So it was very specialized. You could only go to a couple of people to get it, and those parts were very expensive. Now, more and more people are offering them, and so there's more parts readily available. That drives the cost down because you don't have a monopoly on the system anymore, and so they can actually start making these a little bit more less expensive. There's also subsidies. The government usually will do rebates or things like that to make it more enticing, and so that's something to consider as well. And again, there's a lot of people that want to do things not only for the money, but because they want to do something that's better for the environment. And with a geothermal system, once they're installed, they have very, very little impact on the environment and work really well. And so that makes them feel better, even though they may not be planning on living in that house long enough for it to ever pay itself back. They know that they've done something good for the environment. Actually, just last week, I did a houseboat on the Willamette outside of Milwaukee, and the whole development all had these systems in them. They even had the newspaper article cut out and put on the furnace. So they were actually using, they were heat pump systems, but they were geothermal heat pump systems. So underneath the boats, there was actually pipes running into the water, and they were using the water as their source of energy. And so they actually had different points in the water where the pipes were going in. And these are a very, very stable, very low maintenance system. They actually had a heating company come in and go through the entire thing. It was original. It was from I want to say 85 or something like that. And everything was still original in it. I think they had to replace one little valve, and everything else worked great. The technicians that came out couldn't believe how well the system was working for them. Trying to see, this didn't have an age on it, I don't think. But it's actually based off of a solar water heating system. Those were very popular in the 70s and 80s. And so they actually just used the same system for this. But especially with a houseboat, you don't have to drill down into the ground. You're not digging in order to put the pipes down. They could just put them in the water, and it worked. So it was a really nice system and got nice and warm in there very quickly. This is one of the new things we're seeing, and I have to laugh when I see them for a couple of reasons. You know, again, in the Portland area, we are in a gas environment, and so gas is always going to be cheaper to heat anything with versus using electricity. But now we have heat pump water heaters, and I hear Clark County utilities touting them on the radio. And again, if you're in an electric only environment, these might not be a bad way to go. So if you can use the a heat pump to heat your air, why couldn't you use it to heat water? And so that's what they've actually done. And so get to the picture here. So basically it is a water heater, but then it's got an air conditioner. It's a heat pump sitting right on top of it. It's got coils, it's got a fan. They definitely get noisy, and it is actually pulling air from the environment, and it is creating heat to put into the water. So it is still using electricity, but it's not just using electric coils in order to heat things. So they even make add-on units. I haven't seen those yet, but I'm sure somebody has done them somewhere around here. The other kind of nice thing is that it does produce cold air, because it's pulling that heat out of the air, it's pulling the cold out of the water, and so it's sending that cold air back out of wherever the water heater is actually located. It can be very cost effective, but would you consider Oregon to be a high air conditioner usage location? And most people would say no. So that's where we have one of the downsides on this. You know, they make a big deal about, hey, we're saving energy. You are saving energy compared to using an electric water heater. And yes, you are. But look at the little picture here. You've got the hot air that it's pulling from wherever the water heater is located, and it's putting that hot air into the water, but it's got to send that cold air somewhere. And so it sends it back into the room where it's at. If your water heater is located somewhere like your basement, that may not be a good thing in the winter, because now you are fighting an air conditioner running in your house to actually keep the house warmer. This one, I have never seen an installation like this, but this is what should be done if they were installing one of these inside of the living space or even a garage, where it's actually pulling air from outside and it's sending the air back outside. I have done dozens and dozens of new construction that have these in them, and I have never seen them do it this way. They always have it in the garage or even in some part of the house, and it is taking hot air from the house and it is putting cold air right back into the house. In the summer, that's a great thing, but it doesn't work real well if you don't have any way to counteract that. So you are taking the heat from your house. Usually that is being created by your furnace. So now you are fighting the thing that's trying to warm your house up to make your house cold again with a heat pump water heater. And again, we're in a heating climate most of the time around here, so you're not going to save any energy at all. You probably, if you're really putting in one of these because you need to, is because you already have an electric heating system for your house. And so now you're using a heat pump to heat your house up and using a heat pump to make your house cold all at the same time. They just don't save energy in this market. If you lived in Florida, they love them there. They work great because it's already hot and humid, and they are pulling that hot air from inside the house and they are making it cold inside. And so they actually get twice the bang for their buck on those kind of things. The other nice thing, if you have an air conditioner or a heat pump and you're using it in cold mode, you're actually dehumidifying the air, so it can help for things like mold and mildew and air quality. So you're actually dehumidifying your house. So they're great if you're in the right environment. But unfortunately, Oregon is not one of those environments. And here's a screenshot I took from Home Depot's website yesterday. This Westinghouse 80-gallon water heater with a 10-year warranty is almost $1,500, and that's not including installation. So you are spending I forgot to put up the cost of an electric water heater, but electric water heaters are $400 or $500 for just a straight electric one. So you are spending $3, sometimes $4. You can see the prices up above for some of these other ones. You're spending at least 2 or 3 or even 4 times the cost on just the water heater itself. And if it is fighting you on heating your house, you're really starting to lose money. We already covered AC climates only. And this is the big thing people don't understand. Do a lot of new construction where there's an 80-gallon water heater in the house and buyers are ecstatic. Oh, great. We never have to worry about running out of hot water. It's an 80-gallon electric water heater though. And if you know a little bit about electric and gas water heaters, even just low-end, typical entry model ones that a builder puts in, will heat a 50-gallon tank of water in an hour up to 120 degrees. An electric water heater of the same size, it can take 2 to 3 hours to get it heated that high. So to compensate for that, builders are putting in much bigger electric water heaters so that there's more water ready to use so that you don't have to worry about heating the entire tank all at once. So you're now heating way more water, so you have standby loss. And again, you're taking way, way, way longer to heat that water. And if you're using a heat pump to do it, you're really starting to lose money on that. And so we see these in some of these new developments. Again, natural gas areas, the homes are heated with gas furnaces, with air conditioners, not heat pumps. And then they're putting in these heat pump water heaters. The builder is doing it because they're trying to make their energy ratings look better. Hey, look, we are using this extremely energy efficient electric water heater that's using a heat pump. But when they take those ratings, they are taking them ignoring the location they're at and ignoring the fact that there are less expensive ways to heat with. And so it looks really good on paper until they start to add it up. And so, yeah, it looks great for the rankings for the builder. So they can show how energy efficient these homes are that they're building. They don't take into the fuel source available, but also, does the builder really care what it's going to cost you to keep running the house after they've sold it to you? They don't. Yeah, they want to look good up front, and afterwards, they don't care that it's going to cost you 3 or 4 times as much to heat your water than if they had just put in a inexpensive 50-gallon gas water heater. And it doesn't pencil out, but they rely on people not paying attention to that. Here's a great little chart I love to show clients, and especially when they've got somebody trying to tell them how energy efficient the totally electric heating system is that they have in their house. So on the left end, you've got, so actually this is fuel cost per kilowatt hour. So how much it would take to create a kilowatt of energy in an hour. Wood is the least expensive, but also you got to go cut it yourself. You got to have a good way to burn it. We're not doing that around here. We just don't do that very much. Coal is actually the next one. Natural gas, let's just say that's about 4.5 cents per kilowatt hour. You got oil, which is just barely above that. Propane is still, it's more expensive, but it's still not bad. And then you look at electricity, and it's at least twice the cost of heating an hour's worth of energy versus natural gas. So it doesn't matter how efficient what you're putting in is. If you're using electricity to do it, you are still spending way more than if you had just put in something that used gas to do it. So still continuing to talk about heat pumps here. I know it's an exciting topic, but especially if you're in an area where you need them, it's actually kind of interesting, and it helps save you money. So ignoring that there's other options if you're in a natural gas environment, heat pumps are getting much more efficient. They are cheaper. It's cheaper to pump heat than to generate it. So instead of turning on electric coils, that's an expensive way to do it. You're now taking heat from the air and pumping it into the house, so it's much less expensive. And so the other thing they do, especially with modern buildings, and we see this in downtown Portland, they know that certain sides of the building are going to get much hotter, much colder, depending on which way they're facing. And so they will actually use the south side of the building for things. That way they're not having to fight the heat on that side. They can make that heat on one side of the building, move it to the other side. We've seen this in several buildings in Portland. And plus, you know, it really depends on where the house is located. So if the conditions are right an air to heat pump is pretty cost effective and energy efficient. Again, you get Central Oregon where you may not have natural gas everywhere. It is more cost effective. This is also ignoring the fact that there's propane available, but people don't like having a big tank on their property a lot of times. They also don't like the large bill to fill it up every time. And so that can be kind of a hindrance to doing it. But a propane furnace is much, much more efficient than putting in an electric heat pump. So it's something to consider as well when you're looking at the actual costs that things are going to cost for you. Geothermal really is starting to reach that tipping point where it might actually pencil out, especially if you're building your dream home that you're going to be there the rest of your life. Putting in a geothermal heat pump system, especially in Central Oregon, makes a lot of sense because then you can also use it to cool your house, not just heat it. And we're seeing them for other things as well. Water heating, pool heating, hot tubs, they are starting to use these for more and more things. Hopefully you guys haven't fallen asleep now. No questions? Okay, good. All right, so home automation. So this is probably what most people think when they hear new technology for homes. And we are seeing a lot more of this. And I probably need to spend some more time adding stuff to this section because every day more and more stuff comes out for this. But I'm talking about the bare basics when it comes to this side of things. But does anybody recognize this house? And usually, once I put this picture up, people do. Now, honestly, I don't know. I think Bill Gates still lives there. But this was the big house he made up on the Puget Sound many, many years ago. And when he built this thing, it was the end-all, be-all for technologically advanced homes. And it probably still is in a lot of ways, even if he hadn't changed anything. And I'm sure he upgraded as much as he upgraded Windows. But this house is pretty impressive, even especially for when it was built. I mean, I remember in school hearing about all the things this house had, and it was just for the geeks in people. This really was a cool house. So, I mean, they would actually give people little badges they would put on, and it would have it imprinted in there what your tastes were and what colors you liked. And so the art would actually change depending on who was in the room. At least at that time, when phones were always hardwired still, if there was nobody in certain parts of the house, the phone didn't ring in that part of the house. It would only ring where there was actually people in the house so they could pick it up. The lights would turn on and off as you entered and left rooms. Said picture displays, the room temperature would adjust. 20, 30 years ago, this was huge. This was just a gigantic technological advancement. Nowadays, you can go to an aisle in Home Depot and actually find a lot of this stuff. It's pretty amazing how things have changed. Let's go to the next one here. So it really isn't a new technology. It's been around for a long time, but thermostats, think even basic. Yeah, we had that little dial on grandma's wall that you just turned one way or the other to make it hot or cold. But then we had the programmable ones that nobody could program because they were such a pain, but those were a huge leap in technological advancements. Remote access thermostats are something that came in much more recently, and even 10 years ago, that was probably just about unheard of. But there were still some there, so people could get them. You had to dial into it, had a modem built in. You would call into it, punch keys, and get it to change the temperatures. Motion sensors that turn lights on and off. That's been around for a while, especially in the industrial world. But moving into the residential world, this was kind of a newer thing, and it was still kind of expensive, still kind of gimmicky, didn't always work right. If it had any kind of timer on it, it was a pain to deal with. My father-in-law was a commercial electrician, and when I first got married, he gave me this timer box because he knew I was looking for a way to control things outside, that it was a giant wheel, and you had to adjust it kind of like a clock, and you would set little things on it. And even then, this was still pretty technologically advanced. Nowadays, that's dinosaur era technology. Motion sensors. Walking in and out of rooms, you can just put in a light switch that has that built in nowadays, and they're just a couple of bucks more than just a regular light switch. Coffee makers. We went to a vacation house for spring break. They had a very old coffee maker that had a little clock flashing 12. And if you could figure out how to program that, you could kind of figure out how to program when to turn it on and turn it off if you wanted it to make its own coffee. That was a huge leap in technology years ago. Nowadays, we've got our Keurigs, which you can program for all of that kind of stuff. That's just second nature. And if you don't have it, people want to know what's wrong with it. But automation needs. So, the things we look to do, obviously you've got to have a way to do them. There's different things like your lighting, your heating, your cooling. There's also controlling your communications, audio, video, internet, security. And the more we advance in society, the more we are becoming dependent on the internet, and security goes along with that as well. So there's been a few things. Structured wiring has been around for a long time. That's actually running the wires through the walls. There's also Z-Wave and Wi-Fi. There's probably 5 or 6 other names for different things, but they're all pretty much similar. So I'm going to stick to these kind of things. But especially structured wiring. In theory, it's low voltage wiring running through the walls, especially if you're building the house, you built it with it. I remember I've been doing this since 1997. And I remember all the homes up in Bethany near Intel and Nike being built. And it was the biggest deal that they were actually wiring up these homes already to have Ethernet cables available in every room of the house with outlets available in every area. Let's see here. There we go, sorry. And especially if you're doing it when the house was built, it's very easy to do. You just run that cheap wiring around. You kind of had to anticipate where you would need things. So you would need to be running it to the rooms you think you'd need it, and then you close up the house and you're finished. In practice, each room is going to have a little box on the wall. I'm looking here in the room I'm at now. There's several of the Ethernet connections on the wall. A lot of people think that's old, antiquated technology. I still have added stuff in my house because it's faster even than wireless. The cables, you've got a bunch of wires in there so you can run different things with it. So computer networking, obviously internet connectivity. Years ago, there might be a house with computers that were connected that weren't connected to the internet. Video, and then also speaker cables, things like that. Each room would obviously need its own connection. It has to connect to a central location. And so when we started seeing these a lot of times in the garage or the master bedroom closet, people thought these were so cool that they were putting these in, and the Intel engineers were loving it because they knew they didn't have to rerun wiring for their home. And so they were able to connect their hubs right in one place and run everything off of that. And it's a great way to do things. And if you do it right, it is still faster than most wireless technologies. And a lot of people really like it that way. So the pros of it, you got direct connection, so much higher connectivity. It can be easy to reconfigure for different things. When we jumped from 10-speed internet to 100 speed, the same wiring worked. We didn't have to upgrade things. When we jumped from 100 to 1,000, sometimes it worked, sometimes it didn't. So you didn't always have to upgrade things. And you didn't have to tear things up in order to do it. A lot of times the old plug didn't need to be changed. You changed what was connected at one end and the other end, and you were good to go. And it was really, really easy to install when the house was being built. I did a lot of inspections for engineers that they wired up that part of the house themselves. The builder allowed them to do it, and they just came in and ran all the low voltage networking wire. And so it cost them hardly anything to have it pre-done and ready to go. And it can be used on very low level automated homes, but also very complex ones. I have done Street of Dreams homes from the 80s that had a lot of automation built into it. And the connectivity was just, the stuff they had in there was incredible. Very huge boxes with all sorts of low voltage wiring running everywhere, all these controllers. So it was actually pretty complex, but very ahead of its time. Nowadays, you can go to Best Buy and buy a little tiny box, and you've got everything that those homes would have had then. So the cons of it, well, if you don't know where you're going to need things, you're just kind of guessing. And so you still see it all the time where the cable guy put the plug on one wall and everyone wants the TV on the far side of the room. And so things have to get rerun, and it can be kind of a pain. The bigger the house, the more expensive it is because you need more wiring, more connections, more plugs. It does add up. And especially if there's a big leap in technology, it can be expensive to upgrade. Originally the round screw-on cable connections were the standard for most stuff, but especially as we went from standard definition to high definition to 4K definition, all of a sudden you needed different wiring. And if you had to run that cable, it became much harder and much more expensive to do. Z-Wave is pretty cool. This is actually a system I have in my house. It's just a form of communication. But you can get a little tiny hub, kind of a Wi-Fi hub basically, and different light switches, different thermostats, different sensors, and you can have it so you can control everything from your phone, from your computer, anywhere you've got any kind of data connection in the world, you can do things. It's kind of the exact opposite. It's like it says, the antithesis, a nice college buzzword there, of structured wiring. So you don't have to worry about wiring. You just can retrofit it into an existing home. Yes, you're going to be replacing light switches or light bulbs or light fixtures, but it is much less expensive to do it this way. It is using wireless communication, and every generation of this gets better and better and more solid, more easy to use. The first generations, you needed to be a techno geek to be able to get this stuff to work, and you had to know how to do if and then programming. And if you ever took basic computer programming in high school like I did, it was pretty simple, but for anybody beyond that, it was very complicated and hard to do. One of the cool things with like the Z-Wave systems I've got in my house is every light switch is its own little repeater. And so it's kind of a Wi-Fi hotspot extender. So even though I've got one end of my home that gets terrible Wi-Fi, because there's light switches between where it gets a good signal all the way to where there's no signal, it keeps repeating it. And so you can actually extend these things into outbuildings. And I've seen people do them in barns, on the back end of their property, just because the signal would travel and it could keep running different things. And so it makes it really nice to be able to extend that network. I won't read this too much. We're doing pretty good on time here. I was a little worried I'd run out of slides. The pros of it can run very, very sophisticated systems pretty simply. There's even blinds you can have that will open and close. You can turn your AC on and off. It's very easy to retrofit because you're not having to rewire things. It's less costly way to automate, and you can build it over time. You don't have to do all of it at once. You get one little thing and add, and then you kind of keep adding. And that's what I did. My own home, I started with a Nest learning thermostat. They were the first one that really came out with this technology, and it was so simple and easy to use that everybody started mimicking it after that. Cool thing about programmable thermostats, they're very easy to change. You got those older programmable thermostats, and this is what made me upgrade. Is every time I changed the batteries in my old thermostat, I had to refigure out how to program it and set it, and it was never right. And then daylight savings would change, and it was just a nightmare to do it. And I wanted things to run efficiently, so I went out and bought this kind of thing. So these things kind of learn for themselves, and all of them do it now. You just turn it on and off at first the way you want it, and then after a while it starts to learn the way you like things. It can tell where you're at, not where you're at, but it can tell if someone's in the house or not. And so if no one's home, it'll turn itself off. If you leave on vacation, you don't have to remember, oh dang it, I didn't turn it off. It knows, wait, there's not been anybody in this house in a few days. It just turns itself down to the lowest setting and keeps the house from freezing, but doesn't run constantly. It will start to learn your daily schedule. It started to learn when we left for school and work, and when someone came home, it would kick back on. and it would just set itself. So it made it really easy. Nest, again, because this is what I have, I showed it, but most of them have this now. They've got an app for your phone, so you can turn it on and off from wherever you're at in the world. If the system isn't working right, you can kind of troubleshoot it even. We talked about auto away. You can set the schedules you want to set, so it makes it very convenient. And I'd have to say one of the biggest pluses about this kind of system, even though they're more expensive, it took me 2 minutes to hook this thing up. And I know what I'm doing, so I had no problem doing it, but I actually had my parents do it, and I didn't have to help them at all. My dad did it like that all on his own. So it made it very easy. It's almost foolproof to install it. And what's really cool with these is before you had to buy a special thermostat for this kind of furnace and that kind of furnace. And if you had a heat pump, you absolutely had to have the right kind of thermostat to run it. But with the Nest or any of the other ones, 95% of heating systems that use a 24-volt system, it just works on them. You don't have to go out and buy a special one to make it actually work for it. And it'll do, especially the newer heating systems, we've got 1, 2, and 3 stage heating systems, which get very expensive but are much more efficient. Cooling systems now have 1 and 2 stages. Heat pumps with auxiliary heat, humidifiers, dehumidifiers, just turning the fan on. All of these things can be controlled really, really easily, much more easily than you ever could with the other ones. And my wife, who is not technologically inclined at all, was able to figure it out no problem too. So it was really nice. Any questions on those kind of things?
No, nothing.
No, we're good. Okay. So technology in air conditioning, that has changed a little bit. They're still basically the same machines, but they have improved their efficiency. They've improved how things work. And so I don't know why they do this, but your heating system has one way of rating energy efficiency. Your air conditioner has another way. Your windows have another way. Your insulation has another way. I don't know why they don't just have one way to measure heat from all of these things. But when it comes to air conditioners, they call it a SEER rating. So the Seasonal Energy Efficiency Ratio. So prior to 1987, most air conditioners were a SEER of 8. After 87, most of them bumped up to a 10. In 2006, the minimum SEER rating was set at 13, so they couldn't make anything that was less efficient than 13. Now you've got 17 and above. I still remember in the Clinton era, it was kind of a funny arbitrary number. They came out with like a, say the lowest level was a 13, and that was their highest selling units for all the manufacturers. Well, they came out with like, you needed to have a minimum of 13.5 instead of making it like another bigger number. And so the manufacturers were all ticked off at them for that because it was just such a weird arbitrary number. It required all of them to revamp everything just for a tiny little increase. So there are much higher rated ones now. And so if we start with like the 1987 level of energy efficiency at an 8 SEER, that would be 0. And then you keep going up from there, you can see how much more efficient things get. And so at the 13 SEER, which I think, I'm not even sure if 13 is the lowest anymore. I want to say it's 14 or 15 even. Now you're at 43 or 47% more efficient than you were at the 8 SEER. But you could even get a 19.5 SEER, which is 59% more efficient. So things definitely are getting more efficient. The problem is the money it costs you to do it. So they've had to change a lot of different things. Coil sizes are different in the air conditioner itself. The components that go inside the furnace are a different size. The lines running between them are a different size. There's different types of compressors in order to change to compress the coolant. And so things changed a lot. So one of the biggest things we run into is, say you've got air conditioners in Oregon tend to last quite a while if you take care of them. But your furnace may die sooner. So you would get somebody that would replace an old furnace with a newer furnace, but their air conditioner was still good. So they would keep that going and they were great and fine. But then all of a sudden the air conditioner dies a few years down the road. And now you're into a newer category of air conditioner where you can't any longer fit the components that need to go into the furnace. They don't fit anymore because they're much bigger. And so we've seen some pretty interesting jerry-rigged setups where they've tried to make it work by recreating bigger, weird shaped sheet metal boxes to try to accommodate it, but it's just not a great way to do it. And so you actually lose some efficiency when they have to do that. So especially when you've got a client that is buying a home where that furnace is at the end of its lifespan, make sure that if you guys are looking into replacing the system, or we're probably going to have to replace it in the next year or so, make sure they start looking at the whole thing. Luckily with my heating system, mine's from 1993, and my air conditioner is it's actually 15 years old and it's still running strong. I keep it serviced every year like I tell my clients to do. My heating guy said that actually I would be good going, because the air conditioner is still doing so well. He said I'd be totally fine putting in a new heating system, leaving the old air conditioner, and they could make it so that it would be easy to retrofit in the new one once that air conditioner went bad. But people don't always do that, and so they end up making themselves a huge headache down the road, or they find that the systems aren't going to be compatible anymore, and so that $6,000 that they put aside to do it might not be enough, because now they're actually replacing more stuff. So it's always good to really involve a good heating contractor if you're getting into that stage of life on your systems. Let's see here. This furnace here, you can see kind of how convoluted some of this plumbing has become, because they're connecting an old system to a new system. It's a high efficiency one, and so they're kind of having to run things a little bit different. Go to this next picture here. They had to patch things, and it's not a big deal if they have to make it work and it works. But sometimes it's not just the heating guy trying to charge your client more. They're actually saying, hey, this just won't work where it's at. It's not going to fit. We're going to have to rip out more than we thought. Sometimes things have to be changed. But those newer guts that go inside the furnaces are definitely more efficient. They've got larger coils, so they've got more surface area. They've gone from just a single stage compressor that runs at 1 speed all the time to a 2-stage, which can run kind of slower or really ramp up. If you're one of those people that I'm not turning my air conditioner on until I get home at night at 6 o'clock and it's 90 degrees outside and my house is 90 degrees inside, and I want that thing to be cold in an hour. So the 2-stage ones can deal with that better versus an older single stage, which you might need to leave it running all day long at a low setting in order to be able to ramp up to cool your house off. ECM, that's electric controlled motor, I believe is what it stands for. I think it says it in a second here. Also, one of the biggest bonuses from air conditioners is they do dehumidify. And so that actually helps cool your house down faster. So a dual or a 2-stage compressor will actually dehumidify a lot faster. We covered that. Undersized air conditioners, they do tend to run longer. If it's too small, if it's an older system, you literally really should be running it all day in the hot months to be able to keep your house at a steady temperature. Because if you only turn it on when it gets really, really hot, then it's working a lot harder and it can actually wear the system out faster. 2 stages, we kind of just covered that. So the new ECM motors, and you see this with the high efficiency furnaces. Electronically commuted, sorry, not controlled, commuted motor. That speed can actually vary. So you'll hear these with the nicer high efficiency motors where you'll hear that motor kind of come on and then you'll hear it spin up more, and then it'll slow down and spin up more. And it's adjusting for the airflow that it needs, for the heat that you need to get in the house. And so it uses less electricity when it doesn't need to. It ramps up when it needs to for those times when it actually needs to be running. One of the complaints I hear from clients with new high efficiency furnaces is, why is it always running? Well, it's running at a lower mode and then ramping up because it's much more efficient to keep your house at a steady temperature than it is to try to wait for it to get down to 40 degrees in your house and then try to get it up to 90 degrees. So it helps with air circulation, keeps things going. It makes your air conditioner much more efficient as well. Let's see, we're almost out of time here, so I don't want to, soft ramp, instead of just going from off to full blast, it can just slowly work its way up and then turn on and off as it needs to. And especially at the low settings, sometimes you won't even hear the thing running, so it's actually really quiet. Humidistats, we really don't have those here. And more motors. Just trying to think. Oh, new refrigerants is one of the other big things too. So if you have an old enough air conditioner, at some point you can't get the coolants anymore that need to run that. So that can be kind of a problem, but they have started phasing out older ones. They have changed coolants from Freon to about 5 different ones over that life. And so every one of them is supposed to be a little bit better for the environment. But talk to your heating guy. That's probably one of the biggest things when it comes to this kind of stuff, is make sure you're actually talking to your heating contractor about the upgrades you need. But that's kind of everything I got today. So I really want to thank all of you for being here. Hopefully the fact no one asked questions meant I did a good job and that you enjoyed it. So thank you very much and have a great day.
Yay, thank you, Chris.